a little bit about me very quickly. I work at Theodo, which is a web consultancy company. I am a full stack developer. We do mainly React apps and React Native websites, and mainly Django backend, but we do a wide range. And I'm also the co-founder of Embolden Her, which is an initiative for women in tech to help them to become leaders in tech. We run events every month, and we also have a coffee network, which is which I run, and it's for linking up women in tech in London. So, how many of you have used GraphQL before? Quite a lot of you, that's great. So yeah, I'll just briefly say what it is. So it's a specification for APIs. It lets the client specify exactly what data it needs, makes it easier to aggregate data from multiple sources, and it uses a type system to describe the data, and it's widely used in the industry. So why should we use GraphQL? Well, it's a better developer experience. We don't have to create a new endpoint for every query that we create. It's got a clearly defined schema, so you it's got a clearly defined schema. It's got a you can have a shared API between your legacy systems, microservices, third-party APIs, etc. And the main benefit that I see with working with React Native is that we avoid over and under fetching, which I will go into more in a moment, but this is really good for mobile devices where they might have limited network connection or not enough data. So it's really helpful there to limit the amount of data that you're using. So I'm going to quickly run through an example of a REST API and why it would have been better to use a GraphQL API. So in this example, we're looking at a message board, and we're going onto the user profile page. We want to get information about that user, just their name, and then we want to get the title of all of their posts, and we want to get the names of their first 3 followers. So with a general REST API, you might be hitting a user endpoint to get all the data about the user, and you can see we get their name, but we also get their address and their birthday, information that's not relevant to what we need on the page. Then you have to make another query to get the information about the posts, and you just wanted the title, but you end up getting the title, the content, and all of the comments. And then you might hit the endpoint to get the followers, and you get all this information about the followers that you don't need, and every single follower, you might have just wanted the last 3 followers. So with a GraphQL API, we can send the query structured exactly how we want it, and we tell it we want the name, we want the title of the post, and we want the last 3 followers, just their names. It means we only have to make one query, and we get exactly the amount of data that we want, avoiding overfetching and underfetching. So this is the way that you interact with GraphQL. There's one endpoint that you send your query to, or your mutation to, and it works like that. So you can see the difference here. The way that you define your queries is using this schema definition language. It's like a syntax that you define the API with. Everything is a type, could be a query or a mutation, and it is like a concise way of defining every possible use case of your API. I have this simple example. I don't know why. I think it's because QuickTime's it's like faded out the side of the screen, so I hope you can still read what's going on. But you can have enum types. We've got like a main to-do type here, and the query type, which has the different queries that you can do, which are the to-do query and the get all to-dos. And And then we define the mutations that you can do. And basically it concisely defines the schema, and it means that you can use tools to see all the different ways that you can use your API very concisely. So yeah, the top level types are the query type and the mutation type, and these are analogous to get and post in a REST API. But yeah. And then the way that it's resolved on the back end is like a tree structure where where the backend will resolve your query. It will split it into its base components and resolve each part individually. So it means like you don't have to write a new resolver for every time you have a new use case for your API. You don't have to write a new endpoint that's going to give the data that you need. You can just send the query in whatever format, and if it's in the correct format, then your backend will know how to handle it. I just briefly talked about GraphQL and its benefits, and I'm now going to talk about an existing React Native app and how we went about migrating it to use GraphQL. And we decided to use Apollo client for the front end for the React Native app. There's like a lot of different GraphQL clients out there that you can use, but we decided to use Apollo because it's like built for use with React. It gives you a lot of freedom in what you do with it, and the documentation is quite good. And another benefit of Apollo that we didn't end up using for this project is the state management that comes for free with it, which is really handy. But yeah, we didn't end up using it in the end. So I'm going to talk about an app that I've worked on. It was a healthcare app for practitioners to log events about things that their patients have done and to log the progress towards the goals. And it had a REST API. The app could not be used offline at all, which was a big problem because all of the care centres had terrible Wi-Fi and terrible signal. And we wanted to have offline capability, and that's something that GraphQL helped us to be able to do. We also wanted to make a family version of the app where friends and family members of the patients could see what their friends and family members have been doing in the centres, and GraphQL helped with that as well, which I'm going to go into. So it's a very simple app. I've drawn some wireframes to demonstrate, but it's a very simple app. It's only like 5 pages. So here we've got like a login page. We've got a timeline view where you can see a timeline of all the events that the customer has done. And then we have these 3 pages that are for they're used for creating, editing, and viewing the events that have happened. So you've got the customer selection page where you pick which customers were involved with the event, then which patients were involved with the event. Then you fill in the event details here, and then you've got the goal details page where you put in which of the goals that the patient has were related to the event. So like this scrolls across and you can select different customers that were involved, and then this scrolls across so you can add extra information about multiple goals for each customer. So yeah, very simple app, not very much to it. But the fact that these 3 pages, this flow is used for both viewing and editing and creating moments made it a bit more complicated. So we decided to go with a gradual approach. As it's like quite a small app with not many pages, you might think that we could do the conversion from REST to GraphQL API all at once, but still it's like dangerous to do that, and yeah, it might introduce bugs. So the good thing about this was that GraphQL, the way we did it, allowed us to do it gradually, incrementally, changing like 1 page at a time. So yeah, we initially started with the timeline page, and initially there was like lots of different endpoints that were being hit on this page to get the icons for the users and all the data to display on the timeline. And then we were able to get rid of all of those and just use the GraphQL endpoint, use just one query for this page to get all the data that we needed, and that was that. Then we went on to convert these pages as well, and yeah, it was very straightforward. So yeah, setting up Apollo for GraphQL for React Native is very simple. We just went from this as our bootstrap to this. You're just importing Apollo client and wrapping your root of your app in it. It's very straightforward. And then to use it is very, very straightforward as well. You can just write your query or your mutation. So this is the mutation. You import GraphQL from Apollo Boost and just wrap your query in that, and then you just use the use mutation hook. And it's very straightforward. It gives you the method to call the mutation and a loading prop, and there's some other props that you can get as well. And then for the query, it's just as simple. You can get the loading error and data. Yeah, you just use the use query hook that comes from GraphQL Apollo. It's very straightforward.
I was wondering why you'd use a hook instead of just call the GraphQL directly, like make the query the GraphQL query.
I mean, it's just a much simpler API when you use the hooks coming from Apollo rather than the older API. This is like the more up-to-date version, but I have used it without hooks on a previous project, a React project, and yeah, it was just a lot more verbose and harder to understand the code, so I think this way is better. So why did this help with our offline capability? Well, the good thing about Apollo is that, or GraphQL, is that you have this fetch policy prop that you can tell for each individual query or mutation you do. You can tell it if you want it to be cached first, which means it will check if it's cached and use the cached version, otherwise it will make the query. Then there's like cache and network, which means it's going to use the cached version of the data if it's there straight away, so it's very quick for the users to get the information, but then it will also make the network call to refresh the data that's in the cache. Then there's like network only if you want it to always be the most up-to-date version, and then there's no cache, which is like you use the network call but you also don't update the version that's in the cache. So this came in very handy, and like the built-in caching that you get with Apollo came in very handy for the offline capability for us, because they didn't want to save data in any readable format to the devices, as it's like a GDPR issue, but with this, yeah, this just made it really straightforward and compliant. In summary, like, it was much easier than we thought it would be to migrate, and doing it incrementally meant that it didn't impact the development speed, and we got no more complaints about bad signal from the support workers in the centers, and yeah, the caching really helped with that. So yeah, this was about how we did it on the front end, very straightforward. On the back end, we had a Django back end, and it was a bit more complex than this, but still like very straightforward. Maybe something I will talk about in future. Yeah, so we wanted to have the queries working offline, but not the mutations, because we didn't want to have to store the data on the device before they get the signal. But it is possible. There's Apollo retry links, which will basically cache the request and retry it when there's signal. And then there's also some like link queue libraries online that you can use with Apollo that will just like queue up all of your requests until you get signal. And we also didn't really use the state management stuff that would have been quite helpful because we were limited time on the project. But yeah, you can read about it on the Apollo GraphQL docs. That's it.
So, thank you for the talk. From the front-end perspective, it's amazing, right? But if you already have a backend which already exposes RESTful API, how do we enable GraphQL there?
It depends, like, is it your own backend that you have access to, or is it like, yeah?
So, like, a one that was going to be the process of migration,
Yeah.
or if there are any tools which can actually map an existing relational database onto GraphQL.
So you can like use any database. It doesn't it doesn't like impact whether you can use GraphQL. But like, yeah, we had our RESTful API in our Django backend initially, and then we converted to using GraphQL instead of REST. And it's just a case of like, we just had the one view which pointed at GraphQL, and then you have to write some resolver functions for specific types, like GraphQL types. But yeah, you can do that incrementally as well. You can keep your, but the resolver functions can do things like querying the database or getting data from elsewhere.
Would you ever use more than one GraphQL like endpoint? Like have one for mutations and one for queries, or would you one backend would just have one GraphQL endpoint?
No, you just have the one, yeah. It means like there's tools like GraphQL that you can use, and it's like it does I've forgotten the name for it, but like it does a special type of query which gives back like all the information about all the different endpoints, all the different types of queries and mutations that are supported by your API, and then you can use GraphQL to like generate mutations and test them out and things. It's really cool, like it's a tool in the browser to do this. And yeah, things like that wouldn't work if you had it split between multiple different ones. Yes. Okay, so your first question was about downsides. Yeah. I'm not sure really if there's any that I can think of, but there probably are. I just much prefer it. I think it's like a better developer experience and less wasteful in terms of the amount of queries you're making. The second question, yes. So when do you know when to use the cache or to actually make the request? So yeah, for each like it depends on like the use case, right? So if you're looking at a page that's you've got data that really needs to be the most up-to-date thing, like for example on like a banking application, you can make that query be network only and it will never use the cache, and it will always get the data straight away. If it's something that's less critical, like I can't think of an example right now, but sorry?
Profile.
Yeah, like a profile page or something. Yeah, you can use cache first and it will check if it's cached, and if it is, yeah, you can do it on like a query by query basis. Like you do it on the front end when you're making the query. So even like on different pages, if you're making the same query, you can have it be cache only on one page and you can have it be network only on another page. It's just completely flexible based on your use case.
So can you also perform data modifications?
So yeah, it's the same, it's using the mutation rather than the query will perform modifications. But it's the same sort of way. On the back end, you write resolver functions for your mutations, which are gonna update the data in whatever way. So if that's like making a call to a third-party API to update something, if that's like writing data to your database, doesn't matter what it is. Cool. Thank you, everyone.